Hello and welcome to Martin Maths. We're continuing with our World Cup series, and in this case we're looking at some more advanced maths, 3D trigonometry, 3D Pythagoras, and volume of sphere. So what we've done is taken a maths question with a cuboid, where we have to get the diagonal length and the angle there. So we're trying to find AC across there, and the length AG there, and using some trigonometry and Pythagoras. And then we're taking that and putting it in the context of a football match, and imagine that that's half of the goal. So my students and I have created a 3D model of this using the dimensions from the BBC website of the football pitch. And we've created this. So if my guest presenter could help me talk about the dimensions. We've created the 6-yard box. So what have we done for a scale drawing?
So for the distance of the penalty spot, we have 12 yards. And we've drawn that to scale to 22 centimeters. Okay,
so that's that distance there, accurately scale accurately drawn to 22 centimeters. And the 6-yard box?
For the 6-yard box, we've drawn it to scale to 10.8 centimeters.
And then the dimensions of the goal are, well, it should be 7.3 there, 7.3 meters. So we've created the goal here, and
to be 14.6 centimeters.
Okay, and you've even put a goalkeeper there. And what is the average height of the goalkeepers of the World Cup, you found?
6'2".
6'2". And we've even coloured in the semicircle of that radius of 6.2. And now we want to take that cuboid and put that model into the football pitch. And imagining if Harry Kane or the other footballers have to shoot a penalty, what's their best chance of scoring? So what angle do they need to do? So we put that into here. Now this one's not drawn to scale, but it's those same dimensions. And if you could talk me through what angle and what distance do the penalty shooters have to take to clear the semicircle that the goalkeeper would be covering?
So we found the angle to be 45.6 degrees.
So that's this angle here between, if I have that as AC and AD. Okay, and then how did we find that length AC? We know that this is the penalty spot, which is 12 yards away from the goal.
We used Pythagoras' theorem to find this AC by doing 12 squared plus 3.6 squared.
Okay, so it was 11 meters but 12 yards. Yes, 11 squared plus 3.65. Square root that to get the 11.59, and then we move that into the three dimensions. So working out. We know that height was 2.44 meters, and that's how you found the distance being 11.84. Okay, and then you use trigonometry to find the angle of 45.6. Now there are some assumptions that we're making, and what are those? About this scale drawing here, or the scale model here. What are we assuming about the football and the goalkeeper?
That the person is kicking the ball in a straight line.
Okay, and precisely a straight line, so not curving the ball. What else are we assuming?
That it doesn't matter if the goalkeeper guesses correctly.
Okay, so we're trying to avoid any of that area that he might have covered. Yeah, what else?
And that the ball's going to bounce in, so it's not going for the crossbar.
Okay, because we've got it right up to that point there, and we're assuming that although it's going right into the corner, it's not hitting the bar and going out. It's almost treating it like a particle. Any other assumptions?
That the reaction time, speed, and jump isn't in count.
Okay, so you're not factoring any tricks or how quickly the goalkeeper's jumping for the ball. Fantastic. The last thing we thought about that might be a higher GCSE question would be the volume of the ball. And we know that the formula for the volume of a ball is
4/3 pi r cubed.
And we found out that the radius of a standard World Cup football is
11 centimeters.
And found
5,575.280 centimeters cubed.
So that's the volume of the football they're kicking. So there's some 3D trigonometry, 3D Pythagoras, and volume of spheres. Thanks for watching. Don't forget to
like and subscribe.
Like, subscribe, and share. And continue watching this World Cup series. So it's bye from all.
Bye.